Okay, so what I want us to do today is to study array lists. We've seen them. We saw them in Computer Science 2. We've used them quite a bit in Greenfoot. Um, Now we're going to study them one more time to make sure that we're ready for the AP exam. So we know what an array is, but the problem with an array is that an array is fixed in size. I need to know exactly how big the array is when I make it. If I want to keep a list in a program and I don't know how many things I'm going to add to that list, or the list needs to grow over time or even shrink as I remove things, then an array is just definitely not what I want to use. Instead, I want to use a list. And there are several types of lists, and we could even make our own lists, but the only list you need to know for the AP exam is array list. So why is it called array list? Well, you don't need to worry about that, but I'll tell you it's because it's made using arrays. Arrays that grow and shrink, and they use coding to simulate that. But just know that it behaves like a list. So what I'm asking us to look at first here is this Java quick reference sheet. So this is all of the methods that could be included on the exam, including, they could also have methods that they've written. But when you're writing an answer to a programming question on the AP exam, these are the methods that you're going to look at. You're going to have this chart. And so let's take a look at these methods from the array list class. We need to know about them. So first of all, when you want to get the size, the number of elements in the list, you say dot size, not dot length like an array, dot size. When you want to add something, you say add. And you see this E? That's because lists take generics. So that E will be what type it is based on when you create the list. So there's that add that actually will return true, telling you that it's successfully added. It will always return true. Then we have a void method add that takes an index. So this is for when you want to add to a specific index in the list. You notice you can add it 0, so that's how you would add to the front. That's a common thing to do. Because otherwise it adds, if you just say this add, it will add to the back. You'll notice that we can put our index from 0 all the way up to including size. Now the last index in an array list is actually one less than the size. So the fact that they let you add its size means that you can also add at the back, just like you would in the regular add method. The way we get elements, we don't use brackets at all, it's always methods, is .get, and then you give it the index you want to get from. We can also set, and the set method, just like the get method, returns the value that is currently at that index. So when you say set, you give it the index you want to set, and the object you want to put there, it will return the original. .remove will simply remove that item from the list, but it will also return it to you. These are the only methods you have to know how to use, and you have this chart to help you do it. So please keep that handy. Okay, so the first thing I want to do is I've made a project called ArrayList Practice. Okay? And let's just start by making a new class, and we'll just call it numList. And I'm just going to write some static methods because these are just going to be very simple classes just for practice. And by making them static, I'll be able to run these methods directly from the workbench without having to create an instance of the class. So I'll just call this method void run. Okay? All right, so if we want to use ArrayList, we need to import it from java.util package. And what we're going to do is we're going to make an array list, and we're going to add to our array list several different numbers. So let's take a look at how we could do that. So I'm going to say array list. And now I have to tell Java not only what, remember, we're creating a variable here. So we have to tell Java what type of variable is it. Okay, Java, it's a variable of type array list. But when you make an array list, you have to go one step further. Because then Java says, great, it's a list. A list of what? You put that in what are called angle brackets, little alligators, less than or greater than signs. We are going to be using integer. You cannot put a primitive in a list. I will not bore you at this time with telling you why that doesn't work. It just doesn't. Okay? You have to use what are called the wrapper classes. So we're used to the primitives Boolean, double, and int. Boolean is replaced by capital B Boolean. Double is replaced by capital D double. And integers are capital I. The most important difference to remember when you have an array, when you have a wrapper class instance, is you cannot use equals equals. You must use dot equals because they are now objects. And lists can only hold objects. All right. So I'm just going to call this nums. And we're going to make it an array list. So we have to say new array list. Now, before Java 7, you had to type in integer again. And then put the open, close parentheses. And you're very likely to see this from time to time, maybe even in a multiple choice question on the AP exam. But you don't actually need this anymore. It will grab it from the left-hand side. Even if I declare it on one step and then make it on the next, I still don't need to fill that in because it'll get it from here. Okay, so that's just something to look out for, that we don't need to put it in those. But we still need the angle brackets. We still need them. We just don't have to type what's in them. That was a big deal when Java 7 came out. They're excited to save you that bit of time. Whatever. I don't think it's that helpful, but okay. All right, now we're going to practice using the methods that we just discussed. We're going to try add, and we'll try both ones, okay? So nums.add, I'm going to add 10. Nums.add 20. Nums.add 30. Okay? And the array list class has a very nice toString. So we can actually just say system.out.println nums. Like that. But we can also print them out individually. For int I equals 0, this should seem very familiar to what you've done with arrays, right? I less than nums, not dot length though, dot size, I plus plus. And I can just simply access them using the get method. So nums.getI. Okay. Just for fun, what if I just want to print out the first number in the list? Well, we would say nums.get, and we give it the index that we want. I could do 0, 1, 2, 3, but 0 is the first element in the list. The last element in the list is at size minus 1. So let's do that. Oh, I'm missing a nums. So I want to access the last number in my list. So I have to say nums.get. And it's going to be located at size minus 1 because size, the last index is always one less than the number of elements in it because we start at 0. So we can print them out using the toString. We can access the first element, we can access the last element, and we could access each one using a for I loop. Okay? Well, let's try running this and see what happens. So because this is a static method, it should appear right here. I don't need to make a new nums list. I can say just select my static void run. You can see that first here, that's the toString. It puts it in square brackets, separated by commas. We correctly accessed the first number and the last number, and we printed the numbers one at a time, 10, 20, 30. All right, the next thing I would like to do is I would like to practice adding at a specific location. So let's add to the front. Notice that all of my adding, when I added the numbers, that they all added in order to back, 10, 20, 30. Let's add the front. So I have to give it the index of 0 and then the number 5. And I'm putting them in numerical order just for fun. Right now, it doesn't really matter. Well, let's find out. What does it do to the value that was there before? Well, what did it do to the 10 that was there before? Yeah, it just moves everything back. That's right. There is indeed. So let's replace it, okay? So I'm going to just say system.out.println. I'm going to print the nums, right? So we can see it there. And then replace it by saying set. Then you set the value at there. And what it would actually do is actually returns the old value. So I could get the old value as well this way and know what I changed. And then you'll see that when we run it, the used to be a 5 is now a 6. So we need to know set. Set's for changing it. We need to know add, that adds to the back. And add at an index will insert it at that index, sliding everything else back. Okay? And I'm adding at the front, but I can add at index 1, 2, 3, all the way up to the end. So we have seen how to get the size with that size. We've seen how to add at the back, add at any index. We've seen how to set. Last thing I want to show you, how do you remove? Nums.remove, we tell it the index that we want to remove from. I'm going to remove the index, the value at index 1. Okay? So the value at index 1 should be the number 10. And so you see that I had 5, 10, 20, 30, but then we called set on index 0 to change it to a 6. We started actually with 10, 20, 30, but we then added to the front by saying add 0 at index 0, 5. Now this is a little confusing because we're using integers. This usually makes more sense because this could be like a string or something. But we then set that value, which instead of inserting it, changes it. And then we removed the 10, and what happened was the size shrunk. We used to have a size 4, now we have a size 3, and everything slides forward. Okay? All right, so that is how we access each one of them. There is one more thing we need to know how to do. We need to know how to do a for each loop. So a for each loop or an enhanced for loop is, instead of doing it like that, I can say integer x in nums. And this is read for each integer x in nums. You use a colon. And in this case, x will become each number. If you plan on doing anything to that list, removing, adding, inserting, changing, you should not use a for each loop. A for each loop is just for accessing it, looking at it, not for changing. You need to change it, you need to do something else. Ideally, use what's called an iterator, but we don't use that in this class, so you can iterate manually like this. But don't do a for each loop that just gets the values. And so you see, I don't have to say get because they're already gotten for me. And so we'll see a one more print now at the end. I'll just print them all on the same line so we can see the difference with the space in between them, okay? So that's a for each loop. You do need to know that syntax. They're quick and easy to write, and you can see it just goes through the list. I just did a print and then a space after it. Okay, the next thing that I'd like to do is I want to talk about removing. Okay, so okay, so in this same project, let's go ahead and make one more class. We're going to call this class JFinder. And JFinder is going to use an array list of type string. So let's go ahead and take a look at that. And we just did a simple class earlier. Let's take a look at how to implement our object-oriented programming here. So we'll import java.util.ArrayList. Notice that when I import, I don't use the angle brackets though. Public class JFinder, and JFinder is going to make an array list. Okay, so we'll say private array list of type string names. Public JFinder and all I want to do is create a blank array list. So names equals new array list, and I don't need the brackets, and I don't need to say string again. Okay, so I'd like to make a method that allows me to add a name to my array list. So I'll say public void add a name. So when somebody calls the add a name method, they need to give me a name to add. And we're going to simply add this name to our array list. So we'll say names.add name. And I'm going to write a to-do, make better, because we're going to come back, we're going to do something a little bit different with that add name in a minute. Because I'm going to show you something that's pretty cool and a skill that's been tested several times on the test. Okay, so that's how we're going to add a name. The next thing I want to do is I want to write a method that prints the names. And we could use a for each loop here, so let's practice it. For what type of things are in my list? String. So I'll say for string name, and the colon is read in, I-N. For string name in names, system.out.print, I'll say the name plus a space. And then after I'm done, I'll just do a blank print line so that it moves down to the next line. Oops, got one too many of these. Not sure why that's all gray. It's kind of weird. Okay. The next thing I want to do is I want us to write some code that gets or that prints only the names that begin with J. You know what? Actually, we're going to do something a little different. We're gonna return an array list. So we're going to say public array list of type string, and we're going to say get J. So this is going to actually run through and create an array list just with the names that have start with the letter J. So if we're returning an array list, we need to make an array list. So this is jnames equals new array list, like so. Okay, so next, we're going to loop through our array. Now, we could use a for each loop here again because I'm not changing it, but let's practice doing the other kind of loop. Int I equals 0, I less than names.size, I plus plus. So you can always use this loop, the I loop, with .get. You can't always use the for each loop, but you do need to know both. All right, we're going to write a statement. First, let's get the string. So we want to say string name. So we need a variable to grab the name, and we'll say names.get I. So we'll get the ith name in the list, and we'll store it in name. Now that we've done that, we're going to ask a question. If name.substring 0 to 1 dot equals the letter J. We'll assume that all the names are capitalized first letters. Then we're going to say jnames.add name. Then when we're done, we can return jnames, and that would be a list of all the names that are beginning with the letter J. We're going to write one more method before we go about testing out this class. We're going to write a remove method. So we're going to say public void remove J's. Remove J. Now, it turns out we could actually do something kind of nifty, and there is a remove all method, but that's not on the AP subset and on the formula chart, so I don't want to use it. But we could use a remove all method. We could call this method here that returns the array list and then say remove all. Okay, so what our plan here is to loop through the list and remove from the list all the names that begin with J. We do not want to use a for each loop. That is an automatic no-no, 0 points on the AP test if you try and remove using that. Absolute no. Do not do it. We could use a for loop as well. We can do this, but we have to manipulate the I, and so I typically don't like to. So when you have to loop through a list and remove certain things, I strongly recommend a while loop. So we're going to say int I equals 0. While I is less than names.size. Remember, our goal is to actually remove from the list all the names that begin with the letter J. But we need to talk about what's going to happen when we do that, okay? So let me just pull up something to draw with right here. So let's say that we have a list, okay, of names. And usually they're shown in square brackets. And let's say we have like Aaron, Mike, Jill, John, Harrison, Frank, Jim. Okay, so we're looping through this list, okay? And we say, okay, Aaron doesn't begin with a J, you're good. Mike, you're good. Jill, your name begins with a J. So you get removed. And the remove method would actually return it to me if I want to use it. But what happens to the rest of this list? It slides down. And so if I advance this index forward, like a for loop does, for loops kind of automatically do I++, guess what I just skipped? Who did I just skip over? I skipped over John. So, I mean, if as long as none of my two J names appeared side by side, I guess it would be okay. But that's a big mistake, and they test it constantly on the AP exam. Dot remove is scary because it slides everything down. And so when you're iterating through the loop, you want to use a while loop and say there's two situations. If the word does not begin with a J, move up I. If the word does begin with a J, remove I and don't move up. Now, we have a while loop that says we're going to keep looping while we're less than the size. Well, this size keeps changing. But it's fine because we check it every time. We're going to check this line every time. So it's quite simple what we're going to do. We're going to say if names.getI dot substring. Well, you know what? I'm not going to do this all in one line. I'm not going to do that because I feel like y'all understand stuff best when I do it on several lines. First, I'm going to get the string value of the name by saying names dot get I. Yes, I could do this like by doing dot and all that stuff, but I'm going to do it kind of vertically, and you can change it if you want. If name dot substring 0 to 1, that's the first letter, dot equals the letter J, then I'm going to remove it. I'm going to say names dot remove. What am I removing? At an index. It is possible to remove given an object. Don't do that. Give it an index. What index are we at? We're at index I. I for index here. If I remove at I, everything's going to slide down, so do not advance the I. I mean, I could just say, while I is less than names.size, I could just remove I, and I'll just remove everything from the front. I don't ever have to advance if I want to remove everything. But else, what if that name did not begin with a J, advance the I, because we're going to skip over it. So that's why I like the while loop. Gives me more control over the index. Okay, that's it. It's time for us to test this out, and then we'll call that a lesson. Okay, so let's check out the J finder. Make sure everything works out. Okay, so let's test it out. So first, we need to make a new JFinder class. Instance, an object. So there's the JFinder class up here, and here's my JFinder object down here. Right? This is the instance of the class. Got a variable named JFinder1. All right, we have these different methods right now. We can print the names, and nothing gets printed because there's nothing in their list. Let's add a name. So I'm going to add the name Hank. I'll add the name Jennifer. Notice they're all in quotes because they're strings. John. Chris, Joseph, Matthew, and Zeb. Okay, let's print our names. You can see that that's all of our names that we've added. What I'm going to do now is I'm going to check out the get J's, which returns an array list. And you'll notice it returns it to me. So I need to catch it. So I'm going to say get, which brings it into my workbench here. And then we can just toString this to check it out. And you'll notice those were the names that began with a J. But the original list is not affected, right? Still got all the names in there. But now I'm going to say remove J. And what we should have is no more names that begin with the letter J. And there they are. You can find it under object, inherited from object, string to string. That's what that is. Okay, so what I want to do now is I want to change the names method. What we're going to do is we're going to keep the names alphabetical. Add alphabetically. So if I add the names alphabetically, this will give me a chance to practice my other add method. So what I want to do is I want to find the right place for this name. So I'm going to say for int I equals 0, I less than names.size, I plus plus. And I is our index that we'll be looking at adding. And what we want to do is realize that if I added index I, then the value that used to be at I will move back at index. So I'm going to loop through until I find something that alphabetically comes after name. If it comes after name, then if it's the first name that comes after name, that's where I need to add it. Let me show you on here. So I don't think I did these in alphabetical, but let me try to just do some changes here. We'll put okay, I think if I do that, that would be good, right? Okay. So this is in alphabetical order, and what I want to do is I would like to add, George, okay? So we're going to add the name George. So what we're going to do is we're going to start here, and we're going to say, do you come after George? And it's going to say, no, I do not come after George, because Aaron is alphabetically before George. Do you come after George? No. It's okay, so I'll move forward. Do you come after George? Yes. And as long as the list is alphabetical, all the rest will as well. This is the index I want to add George to. Because when I add George there, these are going to all slide to the right, and George is going to go right there. So let's do that. So we're going to ask the question. We're going to say string name. Oh, I already have name as a I'll say, how about current name equals names.getI. And I'm going to ask the question. Do you come after name? Current name dot compare to name. Now, if the compare to method says that it will return a positive number, you know what? Let's not just do it from memory. Let's pull up the chart. This is one of our methods. Returns a value that is less than 0 if this. What does that mean? What does this mean? This is this is the object you called it on. This dot compare to other. This dot compare to that. If this is less than the other, less than in strings means alphabetically before. Greater than 0 means it is greater than the other. So if this returns something greater than 0, if current name dot compared to name, we could have written it the other way well. But if this dot compared to that is positive, that means this comes after that. Then we need to add. We need to say names dot add at index I, give it the index first, then the object. And then I don't want to add again, so I return. I could also say break to break the loop, but let's use return. Even though I'm not returning anything in this method, it's a void method, I can still say return to stop. Okay? One other issue, though, what if what we're trying to add is actually at the end of the list? Like if I was going to try and add Zeb right now. Zeb would never, I would never find a word after Zeb, and this is true the first time we try and add to the list as well. So if we get through this list and we never added, we'll get here, then we just need to say names.add_name. That's what we need to do to make sure that it will add when it's either the first name you're adding or it's alphabetically the last one. All right, so all we got to do now is check that. Okay, so let's make a new JFinder, and I'll add some names to it. We'll say we'll add about Jed, Lucas, Aura, Sue, Caleb, I'm going to add just a few more. That was my family. You can add yours. Mike. Oh, how about Aaron? And one more. Zeb. Okay, and then I'm going to say print names. And we should get everything in alphabetical order. And we do. So that's kind of a cool trick, huh? All right. Well, that's it. Now you're ready to do some exercises.